Equal 1906 minimal absolute difference queries to give us an integer nonce and also a two-dimensional integer query. So it need to return a length of which have an integer array which have length of queries. See this query is two-dimensional array. For each element, it is a query which means the left interval and the right interval for index of these nonce. And we need to find for each query the minimal absolute differences under this range. So let's look at example one, right? 0, 1, because there is only two elements, so the minimal absolute differences is just three, one three difference. And look at the 0, 3, right? 0, 3. So what is the minimal? Is 3 and 4. It has 1, right? So um, this is a question. Well, look at the num range is 10 to the power 5. So if every time for each range we use a for loop, what is the query number? Query is 2 to the power fourth, right? If for every range we try to find use two for loops, um, for each one it will be to check the pairs, it's 10 to the power 10, right? Apparently not that good. And also, if we have this query, multiple by query, brute force apparently is not good. So let's look at this nonce has a range from 1 to 100. So if for each query, we can do some pre-processing and try to see in this range. Um, we should try to use this nonce range as what what we can write. So we should try to have those kind of follow-ups in this range and trying to set this and just trying to iterate just once. That will be a good approach. Or this core just once, right? So how can we do for this kind of small number change, right? Actually, we can do prefix sum for create a prefix sum for every number from 1 to 100. So we write a prefix sum array, right? For each number, uh, we um, we have a prefix sum, right? Um, so when we go through this nums array, we update this prefix sum array. This 100, we'll say set this be 100 multiplied by n, right? This is length n. So every time we go through this number, we just add a one to one of the prefix sum array. We use this prefix sum array for the query to do the O1 query whether it exists or not, right? So let's rewrite code for this. Um, we're going to have int n equals nums dot length, and we're going to have something called a two-dimensional array called a prefix sum. Let's call prefix sum array, okay, because new int. So we can set this one as 101, right? So for each number, we have a prefix sum, and the length will be n plus 1, right? So let's compose this prefix array, right? For int, the value equals we can set it from 1, right? Because 0 will never be used, and value is smaller equal to 100. let's say one smaller than 101, right? V plus plus. Then what we do is that for int I equals 1, I smaller than n plus 1, I plus plus, right? So I say prefix sum array vi would be prefix sum vi I minus 1. And we are going to add 1 or 0, right? Depend on these nums I minus 1 equals v or not, right? So if it is v, we'll add 1, otherwise just add 0, right? So this is the pre-processing. Um, then what we do is that we'll have int q equals queries dot length, right? So we're going to have int result equals new int q. Then for int I equals 0, I smaller than q, I plus plus, right? Then um, um, we have this one, right? So um, we can have int query. Let's say int left, right? Equals queries I 0, and the right equals queries I 1, right? So how can we look whether whether this number exists or not? Um, from this left to right. So we still need to look at from the 1 to 100, right? Whether in this range they exist or not. We can have Boolean exists, right? Equals new Boolean 101, right? So what we do is the for int v equals 1, v smaller than 101, right? V plus plus. So we're going to see pre exists v equals prefix sum array v r plus 1 minus prefix sum v left, this one greater than 0, right? So we create a exist array uh, which we can see whether there is number in this bucket, right? Um, so then we just iterate from um, from this number each bucket, right? So we need to have an int pre equals -1. Then what we do is for int v equals, so we'll see this bucket is from 1, v smaller than 101, right? V plus plus. Then what we do is if exists v, right? Then um, we're going to have pre equals v, right? And also, let's see, if pre doesn't equal to -1, so pre doesn't equal to -1, right? Then we're going to have um, answers. We're going to, let's say, these answers equals integer dot max value. Then answers equals max dot mean answers in the v minus pre, right? So then we just set this result I what be if answers equals integer dot max value, it will set as -1, right? Set as -1. Otherwise, we're going to have set this one as answers. So in the end, we just return result. Let's say this will be an 100 multiple by n time complexity. And this query, right? For each query, that is we processing that is this is just a 100. This is actually constant 100 multiplied by constant, right? So also this is also a 100 operation. So this is a OQ operation, right? This for loop. So the total time complexity will be O(n) plus Q. In space, this is O(n), right? Let's also write a Python code for this. N equals the length norms. So we're going to have a prefix sum array equals this one multiplied by n plus 1 for underscore in range 101, right? Then for v in range from 1 to 101, for I in range from 1 to n plus 1, right? So we're going to have a prefix sum array vi equals prefix sum array vi minus 1, right? Plus what? It may be 1 or not, right? So it is 1. 1 if nonce I minus 1 equals v. Else there, right? So result equals, let's set the result. So for left, right in queries, we're going to have exists equals false multiplied by 101. And for v in range from 1 to 101, we're going to have if exists v r plus 1 is greater than exists v left. So we're going to have exists if prefix sum array, right? Prefix sum array equal greater than, then we're going to have exists v equals true. Then what we do is after pre-processing is we're going to have a pre equals -1, answers equals float inf. Then what we do is for way in range from 1 to 101, we're going to have if exists way, um, then we're going to have preset as way, right? And before we set as way, we'll check if pre doesn't equal to -1, we're going to have answers equals mean answers way minus 3. So we'll set um here, right? So we will have result append. So -1 if answer is equals float f, else will be else answers. So in the end, just return result. Pre equals -1 float syntax error. Pre equals -1. We should add, let's write a new line. Okay.